We've talked about factoring a GCF out of a binomial or trinomial, where GCF represents the common terms or the common factors that each term in the polynomial has. Today we're going to be factoring trinomials into two separate binomials. And we're going to be working with trinomials that have the form x squared plus bx plus c. And all that means is that our x squared coefficient is going to be 1, and b and c represent some number. So let's take a look at two binomials that are multiplied together. This is what we've been doing in the past as well. We've been taking something like x plus 3 times x plus 5 and distributing to get our new answer. So we'll have x times x is x squared, x times 5 would give us 5x, 3 times x is 3x, and then we do a 3 times 5. And when we combine like terms, that gives us x squared plus 8x plus 15. So today what we're going to be doing is starting with this trinomial and working our way backwards. So our answers are actually going to look like two binomials today. And the first step in this is when you're factoring a trinomial, you're wanting to look for two factors of the back number. And we are looking for these factors that are going to add up to give us the middle number. So if you look at this 15, there are several factors of 15, but the only two that would make sense would be 3 and 5. 3 times 5 give us 15, and 3 plus 5 also add together to give us 8. So it's kind of like a puzzle that we're working out today. Let's take a look at example 1. We have x squared plus 7x plus 12. So what we're going to do first is look at this 12, and we're going to think of factors of 12 that can add to give us 7. So one thing that helps some people starting out is to make a list. We have 1 times 12. We've got 2 times 6. And we have 3 times 4. Now 1 plus 12 would give us 13. And that's not going to work because obviously 13 isn't 7. 2 plus 6 would be 8, and 3 plus 4 is 7. So since we're trying to get 7, that means that 3 and 4 are going to be our factors. So what we'll do is write our binomial parentheses here, and these factors are going to go in the back of the parentheses. Since 7 is positive, we need a positive 3 and a positive 4 to add up to give us positive 7. And the things that remain in the blank, we're just going to take this x squared and take the square root of it. Square root of x squared would be x. And so we've got x plus 3 times x plus 4. And the great thing about factoring is that once you get an answer, you can always check to see whether you got the right answer. So there's really no excuse for ever having the wrong answer. So let's take our x plus 3 and our x plus 4 and just check. X times x would give me x squared. X times 4 is 4x. 3 times x would be 3x. And 3 times 4 is 12. Combining our like terms would give us 7x plus 12. And since that is what I started with up here, I know that x plus 3 times x plus 4 is my answer. Example 2 is just a little bit different, but it's basically going to be worked out the same way. We are looking at our 42, our C term, and we want to find factors that will add up to give us negative 17. So obviously 1 times 42 is not going to work. Let's try something that's going to be a little bit closer to home, hopefully. We know that 42 is divisible by 2, so we've got 2 times 21, and 2 plus 21 would be 23, so that's not going to work. 42 is also divisible by 3. 3 times 14 would work. 3 plus 14 is 17, and since that's the number we're trying to get, we know that we found our factors, so we'll be using 3 and 14 here. So let's draw our parentheses. We're going to be having an x, we'll have a 3, we'll have another x, and a 14. This one is a little bit different than our other one because this time, instead of having a plus sign like we did in example 1, we have a minus sign before our b term. And what that means is we need to make sure that the numbers we're adding are going to give us negative 17. So the sign combinations, we're going to use negative 3 and negative 14 because negative 3 times negative 14 would give us positive 42, but negative 3 plus negative 14 adds to give us negative 17. Once again, if I'm unsure, I can check my answer. So x times x will be x squared. X times negative 14 is negative 14x. Negative 3 times x is negative 3x. And negative 3 times negative 14 is positive 42. The like terms are in the middle. Negative 14 minus 3 is negative 17. That is definitely what we started with, so I know that I've got the correct answer. Okay, example 3 differs slightly from what we've been doing in that this time, instead of having a plus c term, we have a minus c term. And the only difference that makes is that this time when we think of factors of 27, we want to think of factors that will multiply to give us 27, but subtract to give us positive 6. So this time, instead of thinking of addition, we're thinking of subtraction. So let's start with 1 and 27. Now, 27 minus 1 would give me 26. So that is definitely out. The next factors that might work would be 3 and 9. 9 minus 3 is 6, and that is the number I want. So we're going to write some parentheses here. We'll use 9 and 3, and I want to give it a positive 6. So the signs, my minus sign is going to go with the 3, and 9 is going to get a plus sign because positive 9 minus 3 is positive 6. And we'll throw the m in the front of those parentheses. Checking our answer. We multiply. M times m would give me m squared. M times negative 3 is negative 3m. 9 times m is 9m. And 9 times negative 3 is negative 27. Combining like terms is definitely going to give me the positive 6 that I need. And so I know that m plus 9 and m minus 3 are my two binomials. Our last example, the B example for example 3, is basically the same concept of our A example where we are looking for subtraction terms, only this time we're trying to get a negative difference. So let's talk about factors of 18. 1 and 18, we know that that won't work pretty much just by right off the bat. So let's try 2 and 9. Now 9 minus 2 would be 7, so that's not going to be it. The next one would be 3 times 6. 6 minus 3 is 3. So we found our factors that we want to use. We're going to be using the 3 and the 6. Now I want to make this a negative number. So this time, instead of saying the 3 is negative and the 6 is positive, I'm going to have to make my 3 positive and my 6 negative, because positive 3 minus 6 is giving me that negative 3 that I need for my middle term. And of course, P is going to be filling in the front of our parentheses. Let's check our answer one more time. P times P is P squared. P times negative 6 is negative 6P. 3 times P is 3P. And 3 times negative 6 is negative 18. Like terms in the middle will give us the negative 3P minus 18, and that is what we started with, so we know that our two binomials here are correct.